So, in order to work with geodata, we need to know two concepts. The first one is the geodetic coordinator system format, which is known as DATUM, and it's a special reference thing, and the other one is the projection. Referring to Wikipedia, a geodetic datum or geodetic system is a coordinate system and a set of reference points used for locating places on Earth or small objects. So it's technically how we locate place on Earth. There are many standards, so it's like using X and Y, but it's not gonna be useful on Earth because it's a sphere. So we are using a new coordinate system named geodetic datum. And so there are many standards for doing so. Many geodetic datums do we have that you can find them in this website named spatialreferencing.org and spatialreference.org, and a more useful format of a standard that is being used in like movies or so, and it is supported by D3, is WGS or World Geodetic System, WGS 84, and also known as EPSG. It's the technical name, this number. And it's the standard longitude and latitude reference that we use in D3. And if you take a look at the JSON format, the type is EPSG, and this is the code. So like these are the property of this standard. And why is it important to know the standard? Why am I even talking about them? Because many geodata comes in different coordinate systems, and so if, for example, if you go for some geodata, so for example this is one of the available ones provided by Government of Canada, and you can download the data sets here. It's boundaries in Canada, and it's like local ones here, and you can find more about the data set. And like for example, this is the JSON format of the data set. It is what we actually pass if you're using this data set. So different places that provide you with data sets for geodetic geodata, they are using different coordinate system. For example, Census Canada uses Lambert confrontal coordinate, or the city of Vancouver uses EPSG 26, 9, 10, I think. For example, for this example, if I go to this metadata section and let's search EPSG, and you see that they are using two different formats, which is not the one I mentioned before. And so you have to, or you need to find this coordinate system, and if they're not the one that is supported by D3 or observable, you need to convert them. Convert these to the original 26, 9, 10 to standard system, and as it stores longitude and latitude of your coordinate. And then you can use different systems. You can download free QGIS tools. You can also use ArcGIS tools. So QGIS tools are those softwares that export maps in format of longitude and latitude, and then ArcGIS are those formats that are Arc. I will cover that part a little bit later, but if you have access to them, you can use them. Some of them are available for SFU, and you can ask Research Commons for GIS softwares, or if you only have a couple of coordinates, you can use this website and which is like online pair conversion, and transform your data into the format you want and then keep them. Okay, so the next thing we wanted to cover was the projection. How you want to flatten. So this was the next section about the projection, and this topic is how you want to flatten your sphere and project your geographical points, or technically how you want to map your locations, your longitude and latitude pairs, which is like a location on Earth, into an XY coordinate on a page, on a 2D page. D3 and Vega Light both provide you with different types of these projections that you can find. You can find some of the D3 ones and Vega Light ones here, or let's see the main documentation page for Vega Light. So this one has many formats, and you can find them. You can find different formats here. Technically, Vega Lights can project two types of data. It can project either geographical points, such as locations on a map, as you can see here, that are represented by longitude and latitude, like what we have here, and or otherwise, let me show you one of these examples, like what we have in today, what we're going to cover today. We can project geographic regions such as countries, states, and so on. So these are covered by GeoJSON format, not longitude and latitude. In Vega, we need to specify the projection type we want to use, and then we need to cover the longitude and latitude as like what are the specific, where do we want to project that. So there are many types available for projection in Vega Light. Let's see them. Available, we can typically use Mercator projection, which is this one, and it's like for most cases it works, and it's like the simple longitude and latitude, but you will probably need to play with different kinds of projection to find the right scaling factor and centering to position your map for yourself in your observable notebook. Okay, now that we know about GeoData, let's see a little bit about data formats. And the file format that is natively supported by D3 is GeoJSON. As you can see here, the format this file has stored geometric data, longitude and latitude under the coordinates value, and in addition to that, if they have any additional value, you can find them under the properties, and in that case the type would be feature, which is usually the case. And data sets such as the one we're going to work with today, which is a Vancouver crime, and I'm going to cover today this one. So we're using two different data sets, Vancouver crime and Vancouver area. One of them is GeoJSON and the other one is TopoJSON. I will cover that later. Anyway, so the Vancouver crimes is GeoJSON, and you can see that each of the elements is a GeoJSON element, and they have type of feature. You can find the coordinates here, and like longitude and latitude, these are the coordinates that we are looking for, and you can find the additional information on the properties. This one is like the vehicular and non-vehicular crimes in Vancouver. And so in data sets, a set of these feature values are contained by an object type feature collection. So we have feature collection, then under feature collection we have different features, like an array of features. Oh, no, this one. Here we have an array of features. Okay, so for each one we have longitude and latitude and describing the geometry, and we have feature collection. I set that one, and then so what you need to do is when you import your data set, you need to export this hierarchy and kind of understand this main structure. What parts are you looking for? What are the properties that you might need to present in your or project in your map, and so on. Okay, so other than that, we have another file format known for D3, which is topo.json. Each of these file formats is organized slightly different, and you need to examine your data to find the key level of the hierarchy to tell D3 what feature you're exactly looking for. For the process of run geo files, you can find those under the feature properties. However, in topo.json is a little bit more complicated. Topo.json is an extension of GeoJSON. However, they follow another format named arc format, as I mentioned previously, as arc GSI converters. Here we are learning about like arc formats. So instead of having the longitude and latitude for each of these points, in topo.json we have arcs, horizontal and vertical arcs, and geometric points are like stitched together from a shared line segments called arcs. In this way, they can store data more efficiently. The other data sets that we are using today is Vancouver area, this one, which is in this format, and so its structure is a little bit more complicated. You can find it in features that, so the type of it specifies each of the points of the map or each of the area, and shows that area with a multi-polygon, and these are the coordinations of that polygon on the map. So like they're covering some geometry data, and yeah, so you see that it finally narrowed down to longitude and latitude values. So topo.json files are usually much smaller, but require a little bit of extra processing in the browser. When you want to display one map, you can potentially lose some details from the original latitude and longitude, and it's more like general, as I said, as it's obvious, like it shows the area instead of like detailed point. So D3 knows how to process these file types. Of course, you can always bring your own data in a CSV format as well, but rendering it will take a little bit more work. All GIS utilities support exporting GeoJSON and topo.json. So if you are working with a GIS software, you can export it either in QGIS or ArcGIS, like GeoJSON and topo.json respectively. And there are also online tools like Map Shaper that you can use. Let me see if I can find it. Like Map Shaper, that lets you load and inspect your geographic data and export it to either GeoJSON or topo.json format. It does not, however, let you convert your coordinate systems. Okay, so enough talking about concepts, let's begin some coding. Okay, so let's begin our coding section. So for the first section, I want to just draw this Vancouver area map, and then adding the crime. So first we're going to use the Vancouver area and draw the map, and then adding the Vancouver crimes data points to it, and then having like an interactive things for the next section. Okay, begin with the coding. I'm defining a Vecolite section. Vecolite. Okay, so specifying the width and height of window, and then we need to specify the data. The values are from Vancouver area. Okay. It should be and then we need to specify the format of that. The format would be topo.json, so the type is topo.json format, and then specify the features. We need to specify the feature of that dataset that we are using, which is Vancouver area size. And then this is about data. The next thing we need to specify is the projection. So how do we want to, what is the projection type that you want to use? Getting back to the previous section, we need to specify the projection type, and so the type would be, as I said, Mercator, and this is usually work for our purpose. Otherwise, you need to find the proper projection type for your purpose. Okay, then specifying the mark of our diagram, which is geo shape, and okay, so I needed to re-import the Vancouver areas because I was using the wrong dataset assembly. So here we have again a topo.json dataset, and the value that is important for us is values on the object, and we are looking for Vancouver area size because they have the geometry and for different parts of for different area, and each of these area has a set of coordinations, the arcs, and so on. So the whole data set is like a little bit smaller. Anyways, getting back to it, so this is a basic map of Vancouver, and then we can add some other features to our map, like under encoding section. um, maybe changing the color based on density and things like that. So encoding, and then I want to fill different values. Filling needs a field. What do I want to fill based on? It's a properties density, and so it's a field under the value of properties. And then we need to specify the type. Specify the type, which is quantitative, and then we need to specify the title, of the color bar next to the map, and using the scale, specifying it a scheme so that we can use like some palette for our color, the grays palette maybe. Okay, let's see how it works. It doesn't work. Weird. Why don't you work? So yeah, so we can change the color based on the color of each area in Vancouver based on a density, and let's add some other features to it. For example, we can separate this area with stroke, and setting the value as black. Okay, better. And so we kind of don't know what is each of these area, and in our data set we know that for each object we have this metadata, we have this property that brings the name of each area, so we can use that and use a tooltip as we learned in the previous session to add some to learn what is each of these sections in the map. So using the tooltip and making two fields. Okay, the first one would be for properties.name, properties name for each of these objects under the geometrics. So name, and the title would be name. For the next field that I want to show in the tooltip is properties dot density, the detailed density for each section, and the title would be maybe this. Good. We cannot have access to them. Oh, my mistake. Okay, so this way I can get each of this area and their density. So this was like using the simple um, one of the data sets that we have, which was Vancouver area, and like showing that map on Vegalite. So I'm going to add a layer to it because in the next step um, we want to add the Vancouver crime data to it. So we need another layer. One of them includes the map, the other one includes the crime. So let's adding them, patching them together. Let's go for the next section that we want to add crime data, and I will click there.